Welcome to the inaugural edition of Recharge the Industry, where we interview the management teams of companies operating in the battery supply chain. In this edition, I am delighted to welcome Epsilon Advanced Materials, which is an anode material producer exposed to a rapidly growing market for battery and cell anodes. Its first project is in India, but it announced a new project in the US in 2023 and is also looking at a project in Finland. And last year, it also acquired Johnson Matthey's LFP Cathode Research Center in Germany. I'm delighted to be joined today by Vikram Handa, the managing director of the company. Vikram, welcome to Recharge. Can I just ask you to give us a short introduction to you and why you got involved with EAM in 2018?
Thank you for having me. Very glad to be here. I actually started the parent company Epsilon Carbon back in 2011. That's when we started our journey into carbon products. We are a specialty carbon company that produce carbon black and other carbon products. And EM was forward integration of our parent company's business. So in 2018, we formed a separate company called Epsilon Advanced Materials, which started off by making coke as an anode precursor. And over the last few years, we forward integrated and are now a synthetic graphite producer as well.
So can you tell me a little bit about the assets that you've got, their production capacity, and your plans for the future with each of them?
So when we started off the business in 2018, we developed a patented technology which converted coal tar pitch into something called bulk meso coke, which is an anode precursor. So we started off with a 2,500 ton a year furnace, and we were selling this coke to tier one Chinese anode companies. And it had very unique properties, giving a high capacity and a high cycle life. And in 2020, we decided to forward integrate and build the whole value chain and go all the way to synthetic graphite. So over the years, we moved from pilot to commercial. And today, what we have is a customer qualification plant, which is a 2,000 ton a year, completely commercialized plant. So from shaping, milling, agglomulation, graphitization, calcining, and coating is all at commercial scale, which we call 2,000 tons a year. And we have scaled up our coke business as well from 2,500 tons to 15,000 tons a year. That scale is allowing us to now further expand our downstream graphite capacity.
Going forward, what's the potential capacity of that plant in India?
What we call today our customer qualification plant has helped us scale up technology, kind of de-risk our scale up as well. What's unique also is that because the parent company is a coal tar pitch manufacturer, we actually manufacture a lot of the additives and the coatings that are used in synthetic graphite as well. So if you look at us, we are 100% self-sufficient, backward integrated facility. We make our own coke, we make synthetic graphite, we coat it ourselves. We actually buy nothing from outside when we make our product, which is quite unique globally, because most synthetic graphite players do buy coke from other sources and have a recipe that they use to make synthetic graphite. Going ahead, when we started thinking of large-scale commercialization, we thought of building a 10,000 ton plant in India. That was maybe in 2022. But we saw how obviously China was evolving and the scale that they were building at. And we decided that our one module is going to be a 30,000 ton facility. So what we are looking right now in India is that we're going to build a 100,000 ton facility in India in phases. So we've announced a $1.1 billion investment into Karnataka in the south of India, where we're located today. Our first phase will be a 30,000 ton facility. And that's exactly what we're looking to replicate in the US and in India as well. So in the last year, we have kind of pivoted to a 30,000 ton a year model, and we are in advanced stages of engineering depending on the location.
You've got the US project that will be modular as well, and Europe. That's probably quite early stage at this stage.
We've been working in Finland, I think, for the last 3 years in a place called Gigavasa, which is a very unique ecosystem that has been created for battery material companies and even cell makers. So we have a partner, the Finnish Minerals Group over there, and we've been working on permitting our project. In Europe, the permitting process is really long drawn. We are progressing well, I would say. We had a last public hearing last month, and we hope to get our permit early next year. and then look forward to starting construction on that facility as well. What's unique in Gigavaasa is they've built some amazing infrastructure with 100% renewable wind power from offshore windmills. And they have a lot of infrastructure around transmission, around water availability, and treatment as well. So it's a unique ecosystem that's created for very power intensive industries like ours.
Okay. I mean, that sort of feeds in nicely to my next question, because obviously you talked about the clean infrastructure in Europe. When we've talked in the past, you've talked about how your Indian capacity can use effectively waste products from nearby industrial assets for a large proportion of your raw material assets. What sort of synergies are you going to get out of your US plant?
In India, we are very unique and very integrated in our facility because obviously the parent company is the same location. And we're also co-located within India's largest steel plant from where we get our raw material. And we have a cement plant and a power plant next to us. So a lot of our byproducts we have customers within a 10-kilometer radius, which is very unique, right? So when we look at our US facility, we want to further localize as much as we can. So what we are doing in the US is we're qualifying US coke sources as well, because eventually we want to have 100% localized supply chain for our customers in the US. We really don't want to be shipping coke from India to the US and then moving products everywhere. So our focus in the US is 100% localized supply chain. I think some products like our coating or maybe 5% would need to be imported from the parent company in India, but it'll be pretty self-reliant as well. I think one of the differentiating factors in the US is the power and the green power availability, right? So you don't have this opportunity for 100% green power source. So we've narrowed down Brunswick County, North Carolina, to build our facility, and we see a roadmap of about 60% carbon neutral power today, which will increase to 80 and eventually to 100 in the next, say, 15 years. That's the roadmap our power supplier has given us.
And I think I probably know the answer to this question, but maybe for our listeners, maybe give it a little bit more detail. How come you chose to fast track your US project ahead of projects in Europe?
So 3 years ago, obviously, Europe was on everybody's mind, and there was a lot of action and movement happening both downstream and upstream in Europe. But I think the Inflation Reduction Act was a great trigger to kind of attract investments and bring focus to the US. So you have cell customers who rather build in the US before Europe. You have battery material companies that would like to be in the US as well. Our actually calling was something else. We were always focused on Korean and Japanese customers as being our initial large customers, because we see the Indian market maturing slowly, and it has matured in the last 3 years, but it still has a few years to go, I believe, till you see really large volumes in India. So we looked at the Koreans and the Japanese, and their always ask was, will you build in the US? So we were very clear that, look, we will build in the US. And then we started working on our project. We went down from 100 sites to 4 sites to 1 site. And it took a long time it took about 9 months to actually narrow down to finally where we chose a site which has power availability, the land, connectivity to a port, good railway connection. The state and the county have been very supportive with incentives and helping us move through the permitting process. So it was mainly the customer that took us to the US, I would say. And then we have worked over the last 2 years to kind of make that project viable.
And obviously, we hear a lot of good things about the US, particularly around the IRA and everything. What sort of challenges do you see around the IRA? I mean, it can't be as easy as everybody makes it out to be.
I think the IRA has been a great trigger to get things moving, and I compare obviously to the Indian market where we are, but I think the IRA highlighted the importance of supply chain, which, usually governments or policy doesn't always identify really what is the critical thing needed for this ecosystem to develop locally. So I think they identified that mining is important, but processing industry, whether it's anode, cathode, or electrolytes, is really critical for the supply chain to develop in the US. So I think from a policy point of view, the IRA was very well framed to highlight that. I think as time has progressed, electrification of vehicles has its own pace. It could go faster or go slower, and a lot of factors affecting that. I see customers committed in electrifying and even building gigafactories to a certain extent. I've not seen that level of commitment from customers on securing supply chain. While the IRA is quite clear, you need to have graphite by 2026, or you need to have the other critical minerals by a certain time. I think the customers have not been so committed to securing or tying up supply chain with strong contracts. I think they see a lot of comfort sourcing still from China. And I think that's a very short term kind of look, because in the long term, you really need your domestic supply chain, and it takes so long to qualify. Companies means that I can tell you firsthand, it's taken us anywhere from 24 to 36 months to qualify with customer sample A, B, C. If the supply chain gets choked out of China, you can't just move to another supplier. And I always give this comparison, say China was to restrict cathode exports. You always have a BSF or Umicore that are global companies that can support you. Even if you look at lithium sources, you have Australia, you have Canada, you have Africa. So you have a lot of places where you can source and still process. But graphite is one of those unique products where so much of that 99% of the processing capacity just sits in China. So you might have coke in the US, or you might have flake graphite in Africa, but all that processing sits there. So it's very important to build processing capacity outside China, whether it's India or the US or Europe as well.
That's something that we've flagged in Battery Materials Review again and again. And obviously, we had the first signs of that at the back end of last year when the Chinese obviously insisted on this new licensing regime for graphite exports. But, while we saw an initial reaction to that, it certainly died down, and we haven't really seen any sort of acceleration in graphite investment. And I think probably one of the reasons for that is that obviously the prevailing graphite price at the moment, spherical graphite price, anode material price, is so low. So what do you think about this issue of differentiated prices, maybe a differentiated pricing environment in the US as opposed to the overriding price in China?
I think there are a few different outlooks here. That does the customer need to pay a higher price for an ex-China supply? I think we already see that on lithium, right? There's a Chinese price and an IRA compliant lithium price. It's totally market driven, and it's happened. I think when you look at graphite, and it's not a very valuable product, but by volume it's a lot. So if you look at a normal four-wheel car and you say it has 100 kgs of graphite, and if the price is you have to pay $5 more than the Chinese supply, that's $500 more. That's not really that bad if you think about it, when you're investing billions in a cell factory and you want to de-risk your supply chain. So I don't think price is the matter. I think customers should be more committed. Even though the export restriction created some kind of urgency at that time, but the fact is there is no supply chain where someone's going to kind of capitalize on that pricing. What we see China doing, surprisingly, is that they just keep dropping their price. They're taking a very aggressive outlook that, look, if we just underprice us for the next year or two, I think in the long run, we're going to be the winners. And we've seen that them do that in other industries as well, like steel. So I think customers should be a little bit more aware that China isn't 40% cheaper in reality. And what they're doing right now is very predatory, and it's going to go back to being expensive because they know you'll have no option. But we have to see how it plays out.
Moving slightly on now. So, what are you thinking now about the slowdown in the EV sector in the US? Does that worry you at all? We've obviously seen a number of cell plants being delayed, potentially put on ice. Could you see the need to delay your own investment plans there?
When we look at a 30,000 ton phase one facility in the US, we don't think it's difficult to sell that, because I think the market is still big enough. Even if you see a slowdown in electrification, you see a slowdown in some of the gigafactories, I think there's enough capacity being built where 30,000 is a drop in the ocean, really, for some of the auto OEMs, right? So we're not so worried about that. As we have qualified sample Cs with customers, we're in the process of negotiating contracts with customers, which we hope, in the next 3 to 6 months, we should be able to make it public as well. But it's important. We are very, very committed to building a project in the US. So we are very clear that, look, we want to be commercially competitive, and we want a customer commitment that helps us fund the project and actually build it. In comparison to a lot of the other, say, battery material companies in the US who are listed, there's always a rat race, right, to raise capital, or how you going to fund projects in the future. So we, being private, don't look at that. We funded the whole business ourselves till today. But going ahead, we need those kind of customer commitments as well to build, because we really think we have an opportunity to build multiple facilities in the US in the next 5 years or so. 30,000 would be just phase one of the first project. But the kind of customer offtakes we see in the pipeline, I think we have an opportunity to build multiple projects for multiple customers.
Okay, I mean, that's fair. So moving away maybe from the US for a little bit, you must be quite excited about the development of the cell industry in India. Perhaps a lot of people don't know, but India's got a flourishing 2 and 3 wheeler sector in electric vehicles, a rapidly growing electric car segment, and ESS is growing very rapidly in line with the renewable energy industry in India as well. So what do you think about the potential for growth in India in the cell industry over the next few years?
India is a very unique market and quite different than the US. So I'll give you a small number. Last year, $3 billion worth of cells were imported into India, right? They went into 2 wheeler, 3 wheeler, buses, and a lot went into ESS. So the kind of push the government has done in the last 5 or 6 years for solar and wind power, there's a huge demand for ESS now. And with cell prices coming down, that sector is really booming fast in India. So with $3 billion worth of cells coming in, maybe in 2 or 3 years, it becoming a $5 billion market, there's a definite opportunity for someone to do cell manufacturing in India and just cater to the existing demand or the growing demand year on year. The challenge in India, or where India sits in this whole roadmap of transition, is that a lot of the Indian companies have kind of taken the outlook to develop their own technology. They've not gone and tied up with the Koreans or the Japanese or the Chinese, even who have mature technologies. So you have customers today that are 1 gigawatt, and then they will go to 5, and then they'll go to 10. So India has to kind of go through this journey. It's already been going through it for the last 3 years. I think it has another 3 years to go. But then we see somewhere in 28, 29, like almost like a hockey stick of production in India, where I think the capacity will grow really fast and the demand will be there as well. So they've taken this outlook to develop their own chemistry and own cells, and companies like Ola or Exide or Amara Raja are doing a very good job and set up really good R&D facilities, material qualification labs. So they're down that path now.
I mean, I've been looking at the Indian market for some time. We've discussed it before. Obviously, I'm pretty excited about the potential of the Indian market, and it seems to be following more of a sort of similar strategy to what we've seen in China, rather than what we've seen in the Western world, where it's very much been the Koreans, the big cell manufacturers that have gone in and tried to develop those industries, and in fact, the smaller local startups have kind of fallen by the wayside a bit.
The good thing is the Indian companies that are in this space have deep pockets, right? So they're able to sustain this developmental journey and obviously invest into it. I mean, two companies, Exide and Amara Raja, are leaders in lead acid batteries globally. So it's a natural transition for them to also enter this space. And they're going by it in a very thought out process. And I'm sure they're going to succeed and scale up in the future.
Okay, something to look forward to. Okay, can we talk a little bit more about your anode manufacturing process now? Obviously, energy is a key component of graphite processing. How do you limit and control the energy usage in your processing?
Over the last 5 years of a pilot production and commercialization, we've looked at two things. One is, what is our power consumption? Because it's so important. We've done a LCA on our on our facility in India, in Finland, and the US. Obviously, in LCA, it gives you a lot of learnings of where we should focus to optimize our process. So, Finland obviously has the lowest carbon footprint. It's about 80% lower than a Chinese synthetic product. India sits at about 75% lower, and the US at about 60% lower. That's again the energy mix that we have. But the other thing that we've done over the last 5 years, we've developed a lot of products, a lot of the equipments ourselves. So in the process of developing products for customers where they want a higher capacity or fast charge capabilities, we've indigenized a lot of the products ourselves. So our shaping milling equipment is our own design, our agglomeration products our own design. We've even patented a particular furnace where we are now doing trials where we think it'll be much lesser energy consumption and still reach that temperature that's needed for graphitization. And obviously we are a coal tar pitch manufacturer at the parent level. So we're able to make a lot of different, say, carbon products based on what is our need to make synthetic graphite. So it could be blending, could be coating, could be surface finishes. So a lot of these things we're able to do in-house, and we're not really dependent on off-the-shelf products. And that's helped our roadmap of customizing and material development over the last 5 years. But yeah, power is very important. It's the largest cost in the process. And I think some of the equipment designs that we have and our furnace technology will help us really be competitive in our large-scale facilities.
That's interesting. And I guess another area where you stand a little bit different to the rest of the industry is with regards to water circularity and also raw materials. Can you talk a little bit about that in your manufacturing approach?
Our process is actually indigenous to synthetic graphite or natural graphite. So we, in the same production line, can produce both. So we have even blended products of natural and synthetic that we provide customers. Obviously, the more mature customers want to blend themselves, but there are a lot of customers out there that would prefer a blended product. So we're able to use flake graphite, we're able to use green or calcined coke, we're able to use bulk meso coke as feedstock. Means they give different yields, but the production line and the equipment remains the same. So we see that also is when we are permitting our projects and in the US and Finland, and people ask, what are you going to build over there? We say we're going to build what the customer wants, right? We have that flexibility of making either product in our production line. But I would say our main focus is synthetic graphite, and that's what we've been focused on because it's a forward integration for us as well. In our process, water consumption is not very high, but that's not a key factor when we look at sites or in our production process. What's important is obviously the emissions and the dust control mechanisms. And around that also our furnace technology and some of the other, say, ancillary equipments around our shaping, milling and agglomeration is quite unique to reduce that.
And how do your products stack up against the Chinese artificial graphite benchmarks, for instance, and also against naturally derived spherical graphites?
I think when you look at the Chinese market, obviously it's really big. But I think there are only 4 or 5 players that make what I would call an export quality product, right? So this is the kind of material performance that Koreans and Japanese cell customers are looking for. And that's really what Europe and North America end users are looking for, right? So I don't think the 1.5 million ton capacity of, say, synthetic graphite out there can cater to the North America demands because they are not able to make the product that customer in that market wants, like what a GM or a Ford wants to put in their car. Mm-hmm. So we have developed products that give a 80% charge in 15 minutes. So these are mainly secondary particle products, and this is what is really the need of the hour by the end user. So I think you have to differentiate material performance, what the customer's needs are, and the process around that. So there's a lot of know-how around the process of making these products because today auto OEMs are setting stiff targets for cell customers are setting up stiff targets for material companies like us, right? They want us to get better and better and better and help them make their cell better. And these are programs we're working on with a lot of the cell customers to do that as well.
And I think it's sort of fair to say that the last few years have been pretty difficult ones for the graphite industry, certainly the listed part of it anyway. Obviously, we've had pretty low pricing, which has impacted profitability outside China. Many commentators, including me, are pretty positive about the structural supply and demand environment for graphite in the medium term. But what do you think needs to change in the industry for pricing to recover?
I think the industry, or especially the market, hasn't understood the complexity of graphite. If you talk to customers, they do say graphite is one of the most important products in the cell. Its fire safety is defined by your graphite. Obviously, your fast charging qualities are defined by your graphite. So, if it's such an important product, why isn't more focus on securing the supply chain or R&D happening? I think from a cost point of view, because the cathode is more valuable, the focus always has been to, hey, let's tie up lithium, let's tie up the cathode manufacturer, let's try to co-locate him. And the focus is to control cost. They focused more on the cathode. I think in the last few years, there's been focus on anode as well. I think there's one disconnect in the market where you have a lot of natural graphite miners who obviously wanted to capture the whole value chain and make active anode material as well. And that's a long learning curve of material development and investments as well. So that hasn't played out very well for a lot of material development, for a lot of natural graphite miners. I think, again, the market just hasn't understood how difficult it is to make. But so what I can tell you what we looked at, right? And we said, look, how do we at the end build these large facilities? I said, look, I need to de-risk the project from an investment point of view. So we are going to invest in the permitting. We're going to invest in commercialization, so the technology scale-up risk is gone. And we're going to get into a solid contract with the customer because we'll have qualified with him. So I look at these three things before I would tap any financial markets to raise any equity, right? I think also in the last 2 years, we've seen it across battery material companies. Developmental money has dried up. People have been talking about commercializing or contracts or non-binding contracts. And after a while, I think the US markets have seen that contract. So I think that's the challenge. But again, I think there are a lot of good companies out there doing good work. And there's a definite, you need lots of winners. You don't need one winner. You need a lot of winners because the market size is going to be so big.
Certainly in this space, you do, yeah.
Yeah. So, you need almost everybody to succeed because the opportunity is there.
Yeah. Okay. Obviously, one of the big moves in anode materials in recent years, probably going forward as well, is the growth of silicon in anodes. Do you see that as a threat for your business or as an opportunity for you?
Definitely an opportunity, and I think it's something you have to do as the graphite company. So in the last 3 years, we've been working on our Gen 1, Gen 2 products as well. We are working on a silicon composite product for customers. So it would be a graphite product mixed with silicon, both either nanosilicon or silicon oxide. We have worked in JDAs with certain companies who are silicon manufacturers, and we try to make a composite project together. And we're also developing our own silicon in our pilot facility and see how we can kind of marry them together. Again, it depends on maturity of customer. Obviously, the Korean and the Japanese would prefer to do it themselves because they've been doing it for a long time. But we see a big size of the market that hasn't understood it well enough and would like a graphite manufacturer to address that and have that bump up in capacity straight out of our product. So there's some challenges on dispersion, how you blend them, and that's the material development journey we're going on. This year, we should be ready with our Gen 1 product, which is about 450 milliamperes capacity.
Okay. And what sort of percentage of silicon is that in the anode?
It's about 8 to 10%.
I can see this being a key area of focus going forward. So maybe we'll just come on and just ask, how do you see the industry, so the graphite industry, the anode industry, growing around the world ex-China, given all of the issues that we've touched on with regards to funding, etc.?
If you look at what our ambition, right, and we want to build 300,000 tons of capacity globally in the next 8 to 10 years, including a large capacity in India, means that requires close to $3.5 billion, right? And maybe there are another 5 companies like this that need to do that as well, right? So it's tough to tap that kind of capital to build this capacity so quick, but the opportunity is there. So I think this is where big money needs to move into these spaces. Yes, there is some risk associated with it, but there's also a lot of opportunity. So far, I have not seen private equity or infra funds move into this space. And we have a lot of discussions with other investors that maybe like battery materials and particularly graphite needs to be looked as an infrastructure investment because it has a really long horizon. It takes long time to qualify, long time to build, and a long payback. So can it be put into that bucket? Can it be put into an ESG climate tech kind of fund bucket? Again, that requires a lot of deep understanding of what is the process, what is your carbon footprint, why should you fall under that bucket. I can tell you in India, there's a lot of investments from global funds going into solar, for example, but they see that so de-risked. They know exactly the cost, they know the risks, they know the contract, the terms and conditions, and they're very happy to fund if everything is stitched up, right? And I'm seeing this level of interest in anodes, especially because they see like who's going to build this and is there an opportunity here. But there's still some risks associated, which companies like us are trying to de-risk. But there needs to be a lot more capital that flows into this space.
Certainly something that we hear regularly in this space. Can you talk a little bit about the sort of regional funding environment? Does the amount of money vary regionally, or are you looking at sort of similar pools of capital in different regions? And also, is the funding environment easier now, or is it harder now than when you were first starting out 3 or 4 years ago?
The funding environmental for developmental has dried up, whether you look at India or the US as well. I think there is funding available for large scale commercial facilities if the project has a certain amount of risk de-risked. So I think that's what companies, us and others, need to work on. In India, we're still looked at as emerging markets. So there's a different bucket of money available in India. Obviously, the US capital markets are very mature. So they look at projects like us and see what is the risk and their appetite around that. A lot of people in the US actually compare battery material companies to hydrogen. And they say, we don't know what is the cost of hydrogen. We don't know how long it'll take to make. We don't know who'll be the off taker. But there is funding going into hydrogen, and the government is also pushing a lot of policy to get hydrogen, funded in the US. So I think it's awareness and it's understanding of what this is. It's a technical product, so it takes some time to understand as well.
I mean, yeah, I would definitely say that we've seen funding moving away from sort of traditional equity and debt markets more towards sort of governments and offtake prepayments, etc., over the past sort of 2 to 3 years as I guess market conditions got a little bit more volatile. Would you say that's fair?
Yeah, definitely. I think also this outlook that people had a few years ago that a DOE grant and a DOE loan will let me build the whole project is not realistic. I think the DOE funding can help certain aspects, but you still need to have equity and debt in the project. Some people have been pitching that, look, it's $500 million. I'll get 150 from this bucket, the DOE loan. I'll get another 100 from the grant. Customer will give me 100, and boom, the project is funded. I don't think it's that easy to do that.
Moving on now, the acquisition of the Johnson Matthey LFP Research Centre. That seems a little non-core. Could you sort of outline your thinking on that acquisition?
So we were actually looking for a year to enter the cathode space. It didn't just happen. And we were very clear we wanted to be an LFP player. We saw again that opportunity of certain waste streams of iron available to us and phosphoric acid being available in India. We looked at obviously a lot of Chinese technologies, and we felt we can't create the same synergy in India that they have because they have a very mature ecosystem of PCAM and CAM in China. I think we were fortunate to get this acquisition of the Johnson Matthey Center. Again, I think quite a mature technology, great know-how, about 150 patents as well. A lot of them commercialized at commercial scale. So where we are today, there was a small gap. I mean, Johnson Matthey kind of paused the whole business, so they kind of withdrew from the market. But we've been in the market for the last now 6, 7 months. We are in the process of scaling up the technology to build a LFP plant in India. Our goal is to be a 100,000 ton LFP player in India, starting off with 10,000 tons. We progressed a lot in doing the engineering for a 10,000 ton facility. And we hope to break ground next year, early next year on the 10,000 ton plant. Material development and customer expectations have also increased in the last few years, and our technology fits right in that perfect bucket of what the customer needs. So we're seeing a really good demand in India and outside India as well for LFP, for non-Chinese LFP sources. We have already started shipping samples and up to a ton level to customers because they've actually qualified with a lot of customers over the last 5 years. So it was almost like going back and saying, okay, guys, let's take off where we left off. I think that's very exciting, and more than half our customers are interested in our LFP. More than half of our anode customers. So I think there's a lot of synergy over there, and we're moving towards a roadmap where maybe some customers we try to marry the anode and cathode and propose a solution to them to sell customers. We're very clear that we're not going to make cells and we're not a cell manufacturer, but we think we can give them a good solution if they were to buy our anode and cathode and kind of give them a recipe to make a good cell.
Sounds like a very interesting sort of business area. So we've talked a lot about your strategy, your plans for world expansion, not quite world domination, but nearly. Any thoughts on a stock market listing sometime in the future, or are you happy to stay private and skate under the radar?
I think that our parent company is bigger. It's much more mature. We've been in that business a long time. So we look at listing the parent company in a couple of years on the Indian stock market, that is. I think today, the battery materials company, we still need to prove ourselves in the industry. So we really look at, building our first facility, commercializing, supplying to customers. And then we would look to tap markets, because if you're going to build another 100,000 tons of capacity, maybe public markets are the best to tap that. But as of now, we look to fund and really establish our first project.
So show you can do it first and then worry about...
But the challenge is to build the first one, you know?
Yeah.
I think after that, it's easier.
And to be fair, I think that's where a lot of battery material developers have come a cropper, because they've tried to list to raise money to try and commercialize without commercializing and then raising money afterwards. And that hasn't worked very well for them.
Yeah. But I think they're undervalued, because the effort that goes into commercialize, I don't know if retail investors or institutional investors have understood the challenges, and I feel they should be appreciated a lot more for their efforts.
Qualification is something that we as specialists talk to people, investors, about an awful lot, and I don't think people really understand the specifics and the specifications of different cell materials and how important the purities and the impurities are to the end client. And certainly commercializing and being able to prove that you can produce to spec on a consistent basis is definitely underestimated by the market, I think.
I'll give you a simple example, which I think we also learned the same way, right? When we started off 4 years ago, we had 3 or 4 synthetic graphite products, primary, secondary, certain particle size, and we were giving it to customers and getting feedback. And then we slowly realized that, okay, we've made something. Yes, it works in our lab, in our coin cell, in our pouch cell, but really we have to make what the customer wants. He's not going to buy what we make. He wants us to make what he wants. And that's the material development journey. Now, fast forward 4 years, we have more than 30 grades of products, because we've been customizing repeatedly, iteratively for customers. And you have to go down that journey. The Chinese have, the Japanese have, we have, others have. And, if you can at the end make what they want, I think they're buyers, because, they're very particular about what they want. And material stability is, I think, more important than material performance to them.
Vikram, thank you very much for your time. And wish you the best of luck for the future.
Thank you very much, Matt. It was great chatting with you.